Good morning to all. I am Karthik, Assistant Professor in Mechanical Engineering Department, SNS College of Technology. As we see in the previous videos, we see about annealing, we see about heat treatment and the first type of heat treatment annealing and its various variations. In this video, we are going to see about normalizing process. The second type of heat treatment is known as normalizing process. As I said in the last video, the annealing, cooling happens inside the furnace itself. That means when the material is exposed to a elevated temperature and it is folded. After holding, it is we are going to we are going to allow the material to cool inside the furnace. Okay. In this second normalizing process, we can see after the material is exposed to the high temperature, it is allowed to cool in the open air. So compared to annealing, in normalizing, the cooling is much faster. For example, if it is in annealing process, if you say 1 degree per Celsius, in normalizing you can say 50 degrees Celsius per second. So this in normalizing, we can simply say the cooling rate is much faster and the cooling time is lesser compared to annealing. So the main objective to do normalizing is to refine the grain structure, remove the strains. As like annealing, it removes the internal stress, to remove the dislocations and also improve the mechanical properties such as strength, hardness, toughness, and to improve the measurability majorly on the low carbon structure. So this normalizing is done at a temperature for steel at A3 line. So at somewhat near the austenite boundaries, this normalizing is done. The third one is that hardening. This hardening, the main purpose of doing hardening is that to increase the hardness of a material. So while doing hardening, the hardening process, a very simple process to understand that once we heat a material, so hold the material and suddenly cool the material. As like we do it for PVC pipes. Once we can, upon heating, it will becomes like a rubber-like thing, and upon soaking, it becomes hardened. So as like this hardening process is done on steels. So the main objective of hardening is to improve the hardness of the material and also to improve the wear resistance of the material. So this hardening has 3 steps. First one is heating, as like heat treatment, heating, soaking, and cooling. The hardening also follows the same. So the second one, what we think about is that how the hardness or what are the factors that affect hardness. Speaking about hardness, the first one is the carbon content. If you increase the hardness of if you want to increase the hardness of a material, we have to increase the carbon content of this metal. So the increasing the carbon percentage will increase the hardness of the material. Second one is that if you cool the materials much faster, so the hardness will improve. As I said about the PVC pipe previously, upon faster cooling, hardness will improve. The third one is that increase in the specimen size. Once the specimen size is increased, decrease in the hardness will take place, if a specimen size increase, there will not be any homogeneous things happening, like heat distribution or load distribution. So upon specimen size increasing, there will be decrease of hardness in certain spaces. The other one is that geometry. So complex shapes have less impact on complex shapes also has the effect on hardness, quenching media, and surface conditions, and what are the allying elements that is used in the material. So these are the factors that improve or alter the hardness of the material. Thank you.